Okay, guys, this is lesson 6, day 2. So, in the past lesson, we talked about solving by getting rid of fractions, fraction busting. We didn't like fractions. Today, we're moving on to radical equations. Now our equations will have cubed roots, square roots, fourth roots, and the like. Basically, bases with fractional exponents. Because if you remember that a square root is the same thing as the 1/2 power. Cubed root is the 1/3 power. So day 2 of lesson 6, we're going to get rid of these things. So I put a 4-step process here. And on this 4-step process, we have some steps here for solving radical equations. The first step is I am always going to try to separate the radical from all else. So in our first example, and the next one will be slightly different, we'll be using the part A group, you only have one radical. And if I only have one radical, I am going to add 2 to both sides, in this particular case, so I can isolate or get the radical by itself. That's part A. Or part 1, sorry. As a subnote to part 1, it says if there is more than one radical, you will try your absolute best to put one radical on the left and one radical on the right. Separate them out and have them that way. 2, you're going to now get rid of the radical by applying the correct power that would allow you to cancel the root out. So if I wanted to get rid of a square root, I'm going to square both sides. If I have a cubed root, I will what?
Cube both sides.
Cube both sides. If I have a fourth root, I will
Fourth both sides.
fourth power both sides. Yes. Now, this one also has a secondary step. Remember that sometimes when you are, what we're going to find out is that if there are 2 radicals and I separate them, I'm going to have to apply foiling techniques, first, outside, inside, last, on one of your sides, which still leaves you with a radical. So you go back to step 1 and separate them again. And then go back to step 2 and apply the correct power. You will do that as many times as necessary to make it so all radicals are gone. And then, of course, once the radicals are gone, in step 3, you can solve for the indicated variable. Now, here's the problem. Because there are square roots going on, or cubed roots, fourth roots, etc., and you are taking them to powers to cancel, what's happening is that we will do things 100% correctly, but they will end up being extra answers. And those extra answers are what we call extraneous solutions. It's kind of like your friend who leans over and says, hey, the answer is 2. Do you just take your friend's word on it that the answer is 2?
Yes.
Yeah.
Probably should never do that. I would at least check it.
Whatever next paper says.
So, guys and gals, you need to take all of your answers that you find in your equation and put them back into the original problem. And make sure they work. Because what happens is even though we do everything right, there will be times that solutions that we find will not actually work. So check, check, check. I cannot stress that enough. If you have the answers and you did not plug them back in because one of them doesn't work, and you don't tell me that, you don't fully understand these problems. Even though you did everything right. It's like finishing it. It's like doing the last step. Does everybody have those steps and we're good to go? Okay, so what I'm going to do is I'm going to take those steps away, or I'll try working on the side, see if I need to take the room. So, what does step number 1 say?
Separate the radical from all.
Okay, so in our example here, what do I have to do? Max?
I don't know. Plus 2.
Plus 2 to both sides. I'm going to move it over here. So that is the cubed root of x minus 5 equals 4. And now, do I have my radical isolated?
Yes.
Yes. How do I get rid of a cubed root?
Cube both sides.
Cube both sides. Bring it to the third power. Does everybody see that the third power will cancel a cubed root? Because remember, to the 1/3, this radical, or here, really means the 1/3 power. And so to make the power equal 1, I'll put a 3. So those cancel each other out. Leaving you with x minus 5 equals 4 to the third power. 4 times 4 is 16. And what's 16 times 4? 64. Okay. And to solve for x, you will need to add 5. So x equals 69. Now, step number 4 says that you better check your answer, because it may not actually work. So I take my work, cubed root of 69 minus 5 minus 2, and it better equal 2. That's the cubed root of 64 minus 2 better equal 2. What is the cubed root of 64? Or what number times itself 3 times is
4.
64? It's 4.
4.
And 4 minus 2 is 2. And is 2 equal 2? Check. So guess what? 69 is the solution to this problem. So the last problem, pretty straightforward, only one radical. This one has 2 radicals. So since they're together, I need to separate the radicals. So I'm going to move the smaller one here. So those are both square roots, aren't they? So that's very interesting. Be careful, those are s's, not 5s. That does make the problem a little bit harder to work with in the beginning, until you realize that it's not an x.
It's an S.
It's an s, yes. I'm not opposed for you to change that variable to an x, but when you go to state your answers, then you need to go back to s. The answer is, the question is in the variable s, not x or t or n or something else. So how do I get rid of a square root? Square. Well, this is kind of nice. If I square a square root, those will cancel, yes?
Yeah.
So this is s minus 48. That's great. But guess what on the right-hand side here? This thing is a binomial, which means when I square it, I really have to FOIL it. I don't distribute the square. So doesn't that really mean it's 8 minus the square root of s times 8 square root of s? And if I want, I can just kind of cancel this out for now because I rewrote it twice. Does everybody understand why I got rid of the square, but I wrote it twice? Squaring means to multiply it to itself. And now, 4-letter F word, FOIL, first times first. 8 times 8? 64. 8 times a negative square root of s is a negative 8 square root of s. A negative square root of s times 8 is a another 8 square root s. Do we have questions? And a negative times negative is a, and what's the square root of s times the square root of s? S. So I think we could simplify that. I'm not going to do anything on the left-hand side for now. I'll just simplify. Can 64 be added to anything? I don't think so. That's not a 5, that's an S. What's negative 8 of square root of s minus another 8 of them? How many you got total here? 16. It's a negative 16 square root s plus s. What do we want to do now? Can I gather? Now look, doesn't that go back to the original problem? I got a problem with a square root in it. Part of our rules here said once you apply the correct power, you may have to repeat steps 1 and 2 again. Steps 1 said separate, wrong way. Separate, get everything that's not a square root to one side, which means subtract s from both sides. That's actually going to work to my advantage, isn't it? The s's are gone in both cases. I'm also going to subtract 64. So those can be gone. So negative 16 square root of s equals, what's negative 48 minus 64? Well, they're both negative, so I can add them.
112.
112? So it's a negative 112. And now to get square root of s by itself, divide both sides by negative 16. Negative divided by a negative is a, and so what's 112 divided by 16? Does that work out nicely? Well, 16 plus 16 is 32. 32 plus 32 is 64. 64 plus 16, 80. That's 5 of them. Another one would be 6 of them. 80 plus 16 is 96. So if I add 16 one more time, does it get to 112?
Yeah.
So that's 7. Everybody okay with that? Yep.
Why is it positive 112?
Because it was originally a negative 112 divided by a negative 16.
Oh.
Negative divided by negative.
Okay.
Positive. And now, to get s by itself, you will square it. What you do to one side, you do to the other. 49 equals s. Yay, there's only one solution I have to check. That's quite nice. Now guys, you don't, for your homework, I mean, you really should show this work, which doesn't take very long. (49 minus 48), right? Plus the square root of 49 should equal 8. What is 49 minus 48? Square root of 1 plus, what's the square root of 49?
7.
Okay. Square root of 1 is? So 1 plus 7 is 8, and 8 equal 8. Check. So therefore, S is 49. If by chance, now granted none of these came up with extraneous solutions, but they very well could. So none of our problems for examples, but what happens if they would have said S also equals 16? Here's the thing. If I put 16, 16 minus 48 is a what? Don't even care what the number is, but what's 16 minus 48? It will be a what kind of number? Negative. Can you square root a negative number? No. So guess what? 16, out. That's how easy this can go to check your work. You pretty much will tell right off the bat if it's going to work, because you can't take a square root of a negative number. You can, in the sense that we can poke an eye out, but we're talking about real solutions here, so therefore something like 16 or anything less than 48 would be a no-go. Does that kind of make sense for everyone? Okay. Now we're moving on to systems of three linear equations. Ladies and gentlemen, if we did this, if I did this to you, covered up the z stuff, x's and y's, you guys would be like, hey, I've seen this before. I've done this before. We've used elimination or substitution. Today we got three equations and three unknowns. We got x, y, and z. The amount of variables you use is the same number of equations you need to solve it. So since we have an x, y, and z, which are three different variables, I need to have three different equations. I am still going to use substitution, and I'm still going to use elimination to solve these. Elimination is my preferred method because it gets rid of variables. But for some people, they are very much stuck on the fact that I need to use substitution. It's okay. Because there are three variables with three equations, the rule of thumb is you have to eliminate two different times. I need to eliminate a variable, so I get down to two variables. And then I'll do the system again with the two variables by eliminating to get to one. So, you're going to have to eliminate two different rounds, or substitution two different rounds, or a mix. But either way, 2 rounds of work. This particular problem in the third equation is missing what? Z. So guess what? The third equation already has a missing variable. I would highly suggest trying to put together the first two to get rid of Z as well. What can you do to get rid of Z in the first two equations? How can I put the first two equations together to get rid of Z? What is the coefficient on Z?
1.
It's -1 on the first one and +1. Isn't that not exactly what I want? So can't I just add them together? If I added those two together, isn't that 2 plus 3, which is 5x, plus 5y. Don't forget to go all the way to our constants over here. 30. Isn't that true? And now I have a system of x's and y's. And that looks a lot like what we've done in the previous lessons. Which variable do you want to get rid of now, x's or y's?
Y's.
Why? It was not wrong. You can get rid of the y's if you want.
Probably x,
Actually, I would get rid of the x's instead. If I got rid of the y's, I'd have to multiply both equations by a number, right? Because 2 does not make a 5 very easily, and a 5 cannot make a 2. But what's in front of x here? Can I change that through multiplication to make it a -5? Yeah, just times it by -5. So I'm going to multiply. Whoops. I'm going to multiply this top equation in the middle here by -5. So I get a -5x plus 10y equals still 0 because -5 times 0 is 0. And then I can add those two together. Those are gone. 15y equals 30. Divide by. So y has to equal 2. This is the hardest part, guys. The hardest part is to finally eliminate or substitute twice to get to a point where you got a variable located or value. The rest of it is just backwalk. Once I know y, plug it back into one of the equations that you have only x's and y's to solve for x. And once I got an x and a y, go back to one of the original equations with x, y, and z, plug in what you know, and solve for the last variable. So, of these three equations that have only x's and y's, top, middle, or bottom, which one are you going to plug 2 into? Top. It's the smallest equation. And look, it has a 0 here. That's awesome. So x minus 2 times 2 equals 0. X minus 4 equals 0. So x equals 4. I like it. So now I have y. I have x and a y. Y, x. Now I'm going to place it back into one of these to solve for z. Which one do you want to solve for? Top one? Okay. 2 times 4. And again, it does not actually matter. I personally probably would choose the bottom one because z is positive there. But that's fine. 8 plus 4 minus z equals, whoop, lost the equal sign there, equals 12? Not 12, wow. 14. 8 plus 4 is equal to 12 minus z equals 14. I'm going to subtract 12. Negative z equals 2. I don't want negative z. I want positive z. So I'm going to divide by negative 1. Z equals negative 2. There's one last thing that I'm going to ask you to do. So we got the right numbers, but this is a system, which means where do they all intersect? It's a point. The point should be x, comma, y, comma, z. So what is it? 4, comma, 2, comma, negative 2. And that is solving the system. Okay, new system. I see this one is fairly friendly. I think we could. Now remember, you've got to get rid of the same variable twice. Each round. Or at least the first round, then you get rid of it again. There's a couple choices. There's one choice right now that stands out to me to get rid of first. Which one? X, Y, or Z? I think Z would be the easiest one to get rid of. Because I don't have to multiply, right? Do you guys realize that if I add 1 and 2 together, the Z's will go away? And then if I add 2 and 3 together, the Z's will go away. There's a positive Z, negative Z. So if I add these two equations together, Z's are gone. But I can go back with these last two and put these two Z's together. So what's x plus 2x?
Wait, how are the Z's gone?
Because I'm adding a positive and a negative Z.
Yeah, but the third Z.
No, we're not adding all three together.
Why did you draw a line then?
I didn't draw a line.
There's a line right there.
I drew an arc saying I'm putting the first two together, and then I'm going to put the last two together.
So they're not connected.
So if I add these two together right now, boom, the top two.
Yeah.
X plus 2x is 3x.
Okay, so 2.
What's 2y plus negative y?
Just y.
It's y. And 4 plus 0
No z.
equals 4. Now, I'm going to go back and I'll color code this. I'm going to add those two together, purple. So I'm going to add these two. What's 2x plus 2x? What's negative y plus a negative 2y?
Negative 3y.
It's a negative 3y. The z's are gone. And 0 plus 1 is 1. Now that system looks a lot like what we've done in the past. Luckily, one of these variables lends itself very easily to cancel each other out. Is that the x's or the y's? I think it's the y's. If I multiply the top equation by what? I'll get rid of y's. 3. I'm going to place it underneath. What's 3 times 3? So that's 9x plus 3y equals 3 times 4? 12. Is everybody with me on this?
Oh, yeah.
Add those two equations together. What's 4 plus 9? So that's a 13x. The 3's, 3y's, and the negative 3y's, gone. And 1 plus 12? Oh, that means x is equal to? Divide by 13. X equals 1. Is everybody with me? Now that I got x equals 1, do I put it into here? No. I'm going to put it into one of these three equations. Which one looks the easiest? I personally think the top one in red is the easiest, because y is already by itself. There is no rhyme or reason other than that. So, 3 times 1 plus y equals 4. What's 3 times 1? So, to get y by itself, subtract it out, so y is equal to? Now that I have x and y, where are you going to put it? Back walk it again. We got to go back to these three, because they have a z's in it, x, y's, and z's. First equation, you can. Second equation, you can. Third equation, you can. Which one do you guys choose, though? I like the first one because z is positive, but I also like the second one because it's set equal to 0. It's a little less numbers to work with. So it does not matter. I'm going to choose the second one. So 2 times 1 minus 1 minus z equals 0. That's 2 minus 1 minus z equals 0. Or what's 2 minus 1? 1. So 1 minus z equals 0. Add z to both sides. Z equals 1. What's the point? 1, 1, 1. Yep. There it is. So it's 1, 1, 1. Now, wait a minute. Remember when we did these systems a couple weeks ago? There could have been times where it all of a sudden came out to 3 equals 3. Or 0 equals 0. What did we say happened? How many solutions were there? All real solutions, right? Or infinite many. Same. What happens if 4 equals a 2? No solution. So no solutions. And I'll go back to this and put it in blue. Infinite many. So be very careful. You have 3 options still, or possibilities, that you're either going to find a point, you're going to find no solution because things just don't make sense. 4 never equals 2. Or you'll get 3 equals 3, or 0 equals 0, or x equals x, those types of things. And that is infinite many solutions. Homework for day 2, lesson 6 is page 52, 8, 9, 11, and 12. Have a great day.